Alright, I made a really long video on subnetting. I was trying to make it short. So what I'm going to try to do here is just make a super short video, hopefully quickly going through how to subnet, and so you guys can go ahead and at least get a little bit of information very quickly. And then, if you're trying to figure it out and you want some more, you can go to that longer video, and hopefully that will fill in some gaps for you. So I'm going to use the second example here with this tens because it's a little easier to use. And we have these three pieces of given information. We have the host IP address, we have this current subnet mask, and we have a new subnet mask we're going to move it to. So what I'm going to do here is I'm going to take all these tens and I'm going to convert it to binary. But I'm going to use a trick here because you see that these are all 255s. Now 255s is all the binary bits turned on. So I know that, and I know that when I do my logical ANDing process that you should have learned about in the book and through lectures and all the other things, the logical ANDing process, when I do that, those three octets are going to stay the same. When I do my math, I'm just going to keep these tens out of it because I already know that they're going to stay the same. Now, what I'm going to worry about is, first of all, I've got this 128, and then I've got this 10 that I need to go and find what it is in binary. So I'm going to go and create a little binary chart here, and I'm going to start a little backwards. Usually you'll start from the right side and start with 1 and start multiplying by 2 to go up. But I'm going to go ahead and just do it backwards because I pretty much memorized these numbers at this point. And I'm going to go ahead and draw these out here. Now, some people like to do it for all 4 octets. For the sake of this example, I'm not going to go into it because I don't want to spend a whole lot of time. Hopefully, make this video very short. So what we're going to do is we're going to take this 10, and we're going to try to subtract the largest number at a time. No, again, I'm going to go super fast, right? We can't take it out of, we can take 8 out of 10 and 2 out of 10. We can't take 4 out of 10. So that's going to be our binary equivalent. This equals 10. That's because we have a 1 in the 2's place and a 1 in the 8's place. You add 8 and 2 together, they're 10. All right? Pretty straightforward. So the next thing we want to do is we want to convert this new subnet mask that we're using. So we have all these 255s, right? So 255, 255, 255. Right, and we know that in binary those are all ones. 128. So can we subtract 128 from 128? Yes, one time. So we'll put a 1, and then we have 0 left, which means we won't have to subtract anything else. We can put all zeros. I'm going to change colors here to this red because now this is our subnet dividing line. Now this is something that I like to use. I haven't seen a whole lot of people use it, but I kind of used it to help me do the math. Now everything on this right side is our network, our host bits, and then here on the left side is our subnet bits. So, and I'm going to go ahead and keep using the red marker because I like it. So subnet bits, we've only borrowed one subnet bit, this 128. I'm going to put 1 here, but I'm going to put that in little parentheses here because in reality we have 8, 16, 24, 25 total subnet bits. So depending on the way, this to me is kind of ambiguous. That word is difficult for me to pronounce. It's a little ambiguous because it doesn't really tell you like, okay, well we borrowed 1 bit, so we have 1 subnet bit. We borrowed, but we have 25 total subnet bits. So like, what's the answer you really want? I don't know. I'm going to put both of them just to hopefully help you conceptualize that total we have 25, we borrowed 1. How many subnets did we create? We borrowed 1 bit. So what we're going to do is we're going to take 2 to the power of how many bits we borrowed, which is 1. So 2 to the power of 1. If you don't know, anything to the power of 1 is itself. 2 to the power of 1 is 2. So we've created 2 subnets. Now, if you're not so math savvy and that sounds really complex and confusing to you, what you can do is you can go, okay, how many options do I have in this with these number of bits? So if I have 1 bit, right? If I have 1 bit, my options are 0 and 1. There's 2 options. Okay, if I have 2 bits, 0, 0, 0, 1, 1, 0, and 1, 1. I have 4 options. Obviously, this gets harder when you start getting like, where you're having to borrow 4 or 5 bits. You're having to do all this little piddly stuff, and the math is a little bit easier. But this may help you get started at least somewhat and go, okay, well, I have 4 different options if I borrow 2 bits. I have 2 options if I borrow 1 bit. But it's 2 to the power of however many bits that you borrow. Okay, so now we've got the subnet bits, subnets created. How many host bits? Right, we took 1 away. We've got 7 left over here on this right side. So I'm going to draw this to help you visualize, hopefully. And this is network. This is our network side. This is our host side. So we've got 7 host bits. All right. How many hosts can we have in 7 bits? Now, the easy way, kind of cheater way to do this is to go, okay, well, we can go look at this and go 128. We have 128 possible combinations on this right side. So with hosts, we have to minus 2. 128 minus 2, of course, is 126. Now, that's kind of a cheater way. The actual math way is 2 to the power of how many bits? Right? So 2 to the 7 minus 2. You take 2 to the 7, that's actually 128. Yeah. And then you minus 2, which gives you 126. That's kind of the long math way to get to the same answer of number of hosts. How are we doing on time? 6 minutes. All right. I'm excited. Network and broadcast. So the network address is all zeros on the host side. Okay. So that would leave us with the network address of 10.10.10. All zeros, 0. All right. Broadcast address, all ones. Now, cheater way, 128, everything to the right side of the 128 equals 127. That's power of 2 binary math thing. All right, so broadcast address 10.10.10.127. All right, what about the other network that we created, just for the sake of completion? The other network we created would have a 1 here in this place, and so we would have the network address of .128. I'm not going to put all the 10s again. What would the broadcast address be? 255. It's the very last in with all the binary bits turned on there. We have this one turned on. All the rest in the host portion would also be turned on for the broadcast address. What are the first and last host addresses? Super easy. Just add 1 here. 10.10.10.1. Subtract 1 there. 10.10.10.126. All right. So we go 1 above the network address, 1 below the broadcast address. Those are all the usable addresses that we have. That's it. All you have to do. Watch the video slower. I talk way too fast. I know. Watch the other video. It's a little bit long, but maybe the explanations will help you a little bit more. I've got a lot more different options kind of there. So if one clicks with you better than another, totally fine. Do math how you want to do it. As long as you come up with the right answer, it doesn't matter. So thank you for viewing, and I'll see you next time.